Alright, so some theorems that we've kind of been using. Just want to make sure that we all are on the same page. So a couple of them you already know, like this one here. Whoops. This one here, all radii of a circle are congruent. I'm pretty sure we're all good with that. This one, we should know now, after watching a video about how to find the center of a circle, that if you make the perpendicular bisector of a chord, if you do two of them, they would cross in the center. So that means the perpendicular bisector of any chord has to pass through the center at some point. So that one we should kind of understand. This one here is kind of what we've been doing most recently. The measure of an inscribed angle is half the measure of the intercepted arc. So that's like where if you have a circle, say this angle here is 80, and then you make another angle, same endpoints, but it goes like to the outside of the circle, like that. So that would be an inscribed angle. So this inscribed angle would be half of the measure of the intercepted arc, which is the 80 to begin with, because of the same endpoints. This one just went to the middle, this one went to the outside. So this one is half of that one. So that's another one that we've looked at. So those three we've already looked at. Now we're going to talk about this one. Talk about this one really quick. So this one, what it's saying is an angle that's inscribed. So we just looked at inscribed angles. This is talking about an angle inscribed in a semicircle. Okay, so in this case, what they're talking about, a semicircle, is half of a circle. So what they're saying, like if these were our endpoints right here, any angle that we inscribe using those endpoints would have to be half of that original angle, which since it's a straight line is 180. So any other angle that we inscribe, whether it's there or like there, or even if we go down here, as long as we use the same endpoints from the semicircle, which is half the diameter, any inscribed angle would have to be 90, because 90 is half of 180. So that one and this one are kind of like the same thing, but a little bit different. So the last one, we'll talk about this now, saying the circumscribed angle and the central angle that intercepts the same arc are supplementary. So if you look at this picture right here, a circumscribed angle is what happens when you draw two lines that are tangent to the circle. Okay, tangent means it gets like right up next to it, but never actually like goes through it. So like this part right here, this would be called like the point of tangency. That's where it gets like right up next to the circle, but doesn't actually like go through it, just kind of barely touches it. Okay, so that is an inscribed angle. Okay, so the reason that and this angle are supplementary is because what they did here is they made a 90 here with a perpendicular bisector and a 90 here, and that'll always happen. So that's 180. Now the angles, this whole shape right here, this shape that I'm outlining is a quadrilateral. So those four angles have to add up to 360. If these two are 90, that's 180. 360 minus 180 would be 180. So that means this angle and this angle here would have to add up to 180 to make it a total of 360.